Hello everyone, welcome to the solution of LeetCode problem 1615 named Maximal Network Rank. In this problem, there is an infrastructure of n cities with some number of roads connecting to the cities. And the road of I is the value A of I and B of I indicates that there is a bidirectional road between cities A and B. Bidirectional means it can be possible to reach city A from B and to reach city B from A. Now, the network rank of two different cities is defined as the total number of directly connected roads to both of the cities. If a road is directly connected to both cities, it is only counted once. Now, the maximum network rank of the infrastructure is the maximum network rank of all of the pairs of the different cities. Now we are given an integer n and array roads. We have to return the maximum network rank of the entire infrastructure. Now in the first example, there are four cities 0, 1, 2, 3. 0 and 1 are connected, 1 and 2 are connected, 1 and 3 are connected, and 0 and 3 are connected. So here for the pair of cities 0 and 1, we can see that there are in total 4 roads connecting to them or passes through them. One is this, and this. This road 0 and 1 is directly connected the cities 0 and 1. So we will consider it one time. So in total there are 4 roads. So we have to return 4. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken another example here. The total number of road is 5 and we are given several connections. Now the first connection is 0, 1. So we have to make the connection here. The second connection is 0, 3. The third connection is 1, 2. The fourth connection is 1, 3. The fifth connection is 2, 3. And the sixth connection is 2, 4. So these are the routes. Now, what is the maximal network rank here? The maximal network rank is these two, and this H. So here we can see that the maximal network rank will be these 5 green roads. If we consider the road 1 and 2, we can see that there are in total 5 roads passing through these 2 of the cities. So here we can say that the total network rank will be 5. But how can we determine or solve this problem? Basically, as this is a pure graph problem, as we have the connection between the roads, let's make the adjacency list. So there is a road between 0 and 1. So we have to insert 1 into the list of 0 and we have to insert 0 into the adjacency list of 1. Now there is a road between 0 and 3. So 3 will be inserted at 0 and 0 will be inserted at the 3. Then 1 and 2. So 2 will be inserted here and 1 will be inserted here. Then there is 1 and 3. So for 1, we will insert 3 and from 3 we will insert 1. So there is 2, 3. In 2 we will insert 3. In 3 we will insert 2. There is 2, 4. In 2 we will insert 4. In 4 we will insert 2. So now it is the adjacency list. That means here we can determine from which cities we can go in which cities. So here from 0 we can go city 1 and 3. From city 1 we can go cities 0, 2, and 3, and so on. Now, we have to scan through this adjacency list, and for each pair of the cities, we have to determine whether there is a strongly connected or there is a directly road between them. Suppose for the city 1 and 2, 1 is here, 2 is here. So we can see that there is a direct connection because in the 1 we have found 2, in the 2 we have found 1. So the cities 1 and 2 is directly connected. So here, what is the size of the adjacency list of 1? It is 3. What is the size of the adjacency list of 2? It is 3. Now, as 1 and 2 is directly connected, so we have to subtract 1 from this. Why we are subtracting 1? Because this road between 1 and 2 is counted 2 times. One is from 1 to 2, another is from 2 to 1. So we have to discard one of them. So that's why the total number of roads passing through the nodes or the cities 1 and 2 will be 5. And we have to repetitively do this process by using the big O of n square time complexity in this adjacency list. After that, for each of the value we have found, we have to return the maximum one. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named maximal network rank, which is integer n, and the road as a parameter. Now we are taking an adjacency list, and for each of the connections between the cities, we have to insert or make the adjacency list. So here we are taking the set data structure because we want to ensure whether one city is presented in another city's adjacency list or not. So set is the suitable data structure here. Now by using this for loop, we are making the adjacency list. Now inside these two nested loops, we are calculating the size of the adjacency list for each of the cities A and B. And first assume that both of the city is not connected. So is connected will be initialized to 0. That means there is no directly connected road between them. Now here, if J is found in the adjacency list of I, that means city I and city J is directly connected. So is connected will be initialized by -1. And the answer will be maximum of answer and A plus B plus is connected. So here, if both of the city is connected or directly connection between the cities is exist, so the answer will be maximum of answer and adjacency list size of the both of the cities -1. Otherwise, if there is no connection, simply this will be the summation of adjacency list size of the both of the cities. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.